What's up? We're here at the the Fall 2024 Engineering Showcase. I'm Trenton, I'm part of ESAB. We kind of organized this whole thing. This is kind of a place for a bunch of the students taking Engineering 697 to show off their capstone project. They've been working on this for at least the full semester. You can see a bunch of different projects from all the engineering disciplines.
Hi, my name is Rashtina Arganwal. I'm a computer engineer and I worked on the SmartStop EV project. My main focus was the software and app development. We used Apple Developer to create the project with using Swift code, and we also programmed an Arduino to go ahead and have the app control the Arduino.
One of the biggest challenges that we had was the GPS that we have attached to the car was getting that to update through our app into our microcontroller and being able to calculate the distance to be able to shut the car off when it went outside of the parameters that we had set.
So the car is fully functional through the app. We have a start button, a stop button, and a get GPS. And hopefully, if it gets approved, we'll have it on the Apple Store for you guys soon.
So for our project, we wanted to create something that would help with climate change. So we found a way to divert fresh water that goes into the storm drains into underground aquifers. So the water goes into the storm drain, down into an underground cistern, and into a dry well where the water gets filtered out into the groundwater. If the system looks like it's about to overflow, it then gets diverted into existing storm drain systems and back into the ocean where water currently goes. So currently all that fresh water that goes to the ocean is just getting put straight into the bay. But we are trying to get some of that water down into the groundwater to help replenish groundwater and find an alternate way to get water since our snow caps are starting to melt, which is one of Northern California's main sources of fresh water. So as a fourth-year civil engineering student, I'm looking to go into sustainable and civil engineering design. So I've applied to master's programs for that exact thing, and I'm hoping to work on making cities more sustainable through civil engineering, just like our research project here.
Hi, I'm Mario. I'm the project manager at our Dampening Tower team. Our main goal here was to construct a balsa wood tower that was in requirements of the seismic design competition for EERI. We wanted to take that a step further, where we're using a dampened tower with a liquid dampener and a tuned mass dampener in order to help reduce the amplitude of earthquakes. We really hope that this would increase the safetiness of an earthquake, that we are in control of natural disasters in the future so that we don't have to have more casualties or even loss of more buildings that we would already have.
Hey everyone, we built these two towers in the last 12 weeks. It was a construction process of over 100 hours, and this is our project.
Working on the TLD was such an eye-opening experience. First, we had to work as a team, and this is something that taught us how to communicate together and work with each other. Most of all, it taught us how to take challenges head-on. Most of us did not know how to use the software, but through this project we were able to see how we can pull together and learn something new. So I really appreciate my team, I appreciate the whole Dampening Tower project for making this possible today. Thank you.
Hi, this is ASFM, stands for Automatic Shirt Folding Machine. My name is Jaden, I'm a mechanical engineering student. Working with me is Mike, which is also mechanical engineering, and Jerry is computer. And the goal of our project is to automate the chore of doing laundry. There's machines that fold, that vacuums, wash dishes. Ours folds laundry. The way that it works is that the user will put a shirt on top of the set of panels. The ultrasonic sensor will let the Arduino know that a shirt is on top, which will sound a buzzer to get the user out of the way before the sequence starts. And the sequence is that we have gear mechanisms that control the panels to fold in different sections of the shirt. And once the folding is complete, we have a trapdoor which will open up and lay the shirts down into a neat stack.
Hello everybody, my name is Roberto Vigil-Ruiz, and this is a motor test station that I built for the SFSU campus. This initially came to be through talks with Dr. Quintero, who is a research professor here on campus. We saw that there was a need for the mechatronics course to have a tool that would enable students to run simulations specifically for prosthetics here on campus. This motor will represent like a knee joint and a prosthetic, and then we have this other motor here which will apply a load to that motor, and students will be able to gather data from it and learn more about actually setting up these stations as well.